Hello students, in this video we'll discuss about the target code generator and especially issues in the design of a code generator. So where we are, so we have started with the lexical analysis, semantic analysis, syntax analysis and intermediate representation, how the code should be represented, that we have covered in the first three and a half units. The last unit, fourth unit, we have discussed about storage organization and activation and of course IR representation also, symbol table management. Now the code actually given to the intermediate rate optimization. So that we'll discuss optimization, whether it is machine independent, that means IR optimization, or machine dependent, that is machine dependent optimization. Okay, so which is going to be occurred after code generation. First, we'll go with the code generation. If an IR or optimized IR is given as input to the target code generator, how it is going to represent in a assembly language code, that we will discuss. So first, what are the issues? Before going to the issues, first, what are the properties and forms? So properties decided by object code generation phase. First of all, when you are representing the code in some target, that should be correct. Means what was the intention of the program in high level. So once it is represented in the low level also, the intention must be same. Means it should be perform the same task. And the quality of the code should be more, and efficient resources, efficient use of resources of target machine. See guys, when you are representing the code in machine, so you may not have the enough sources like registers. So you should take care about the efficient use of available resources. And the last one, the quick code generation, means it should take the less time. And what are the forms of object code? So there are absolute code, relocatable machine code and assembly language code. See, as we have already discussed in the language processor in first unit, so once the code is given into the compiler, then it will give you the assembly language code. So where it is going to be in the move, like mul, add, subtraction, like that. And once it is given as input to the assembler, then it will give you the object code. Okay, so that object code, sometimes you may not have the different compiler and assembler in that case. So then we can say that machine relocatable code, once it is given as right assembler, after assembler, machine relocatable code. What does it mean? See, the code is actually stored in the hard disk from some memory. Hard disk means logically existed memory, right? But if you want to execute, that should be executed in the main memory. So this code, whichever in the hard disk, that is called machine relocatable code, which are going to be right executed separately every module. So once compilation, linking and loading, everything is done, then that will give you the absolute code. So that actually is stored in the actual addresses, means RAM. So WT, FIV and PL by C produces directly absolute code once the compiler is done. But some generate only assembly code like C. Some generate directly machine relocatable code. So we have, based on the programming language and operating system, the forms of object code may be different. Then what are the issues while you are designing a code generator? So first of all, the code should be correct, high quality. So this we have already discussed. Right, then coming to the input to the code generator. Right. So the first property is correct code. We have already discussed about this. The second issue while you are designing a code generator, what is the input you are giving to the code generator? Whether you are giving only the intermediate representation or even you are giving symbol table entries also, right? So because the front end produces low level languages, whether we can use the same names or whether we have to use the machine instructions. So whether already syntactic semantic errors are detected or not. So these are the things you should take care before giving something to the code generator. Then third issue is target program. So once the input is given to the target code, where you are representing that. whether based on the targeting architecture, right, then you have to represent the code, like whether you are using RASC or CASC or stack based machines, what you are using. Okay, so then based on that architecture we have to develop the instruction. For example, sometimes you may have only two operands like this, sometimes you may have four, right, three, sorry, A, B, C, the destination. So well, depends, right, based on the architecture the instruction should be different. So you have to mention what you are using, then which kind of memory you are using, like whether the runtime memory or static memory, how they are mapping the logical address to physical address, what kind of symbol table you are using, whether what kind of intermediate representation, is it 3 address code, and how the jumping is happening, whether you are using 2 pass, single pass compiler. So these kind of memory management should be taken care, right? Then these are the issues while you are generating correct code: input of the code generator, the target program, memory management. And there are few other issues also. And before that, what are the tasks of code generator? First one, you have to select the appropriate instructions. Like if it is B plus C, so what is the instruction you have to use? Add or load, what kind of instruction we are using in the evaluation. So that is a primary task of any target code generator. So once the choosing of instruction is done, how many registers you are using, the register allocation, and how you are assigning those registers. As I told you, the main problem with the registers is they are low in count, right? So why they are low in count? Because they are high in cost and they are fast accessing devices. So there's a reason you should take care about the, right. There's a one more major task of code generator, and the last one is ordering of instructions. See, changing the order sometimes increase the process, right? So for example, you may have some statement in the loop which is constant. You can change the position of that statement, automatically it reduces statements in the loop. So that we'll discuss in the machine dependent optimization. At the time we'll go for it. So first one, the instruction selection, the first task of code generator. So how this IR is mapped into target code. So what is the level of intermediate representation, and what is the nature of instruction you are using, and what is the desired quality of the generated code. These things you should consider while you are selecting the instructions. Okay. So then for example, if you have an instruction like this, x equivalent to y plus z. So simply first you have to load the y, then you have to add it with the R naught, then again you have to store the result back to the X. So these are simple instructions we have. See, first you have to bring the value from the Y. That's the reason I am taking it in the load R naught comma Y. So bringing the Y to the register. So then I am performing the addition of R naught and Z, then I am storing in the R naught. Assume that there is a single instruction R0. If not, you can even bring this Z to the R1 so that you can make the processes fast, right? Then storing back the result to R naught to X, because our targeting register is variable is X. Then same way you can do this, first load, then add it to the C, then store the A back to it. But see, just we got the result of B plus C in the A naught, sorry, R naught. But first we have to store in A, that's why I issued a store instruction. But again you have to add it with the E, so immediately I issued a load instruction. Even though the R naught value, if you store it and load it, if you do it or if you don't do it, but the result of R naught is a B plus C only. Again storing it to A, bringing it is useless. So such instructions you are not going to select it. So that comes first, instruction selection. And coming to the next one, register allocation. See, we have register allocation means selecting a set of variables that resides in the registers at each point of the program. Okay. So first, how many registers, how many variables should reside in the registers, right? And specifying which register, where, how many we have to store in the registers and which has to be stored in the register. Selecting a specific register where we have to store. So these are the two tasks of code generator, right? So of course here see, assume that we are having two registers, then you can store A in R1, B in right load R1, then add it, then multiply it. Okay, so then you can keep two different variables so that we are not losing the value of R1. See, let me go with this. For example, A plus B, first load R1 comma A, loading the A value to the R1. Then after that, what you have to do, you have to add it A and B, but this R1 is having the result of A plus B. But in the next instruction, we are not using result and we are not using A or B. So there is a reason what we have to do here. We have to take C to the another variable. So that next we can perform the multiplication of R0 and C. You cannot change this R0 because we are multiplying with that C, right? So we need two variables, two registers, sorry. Like that, you have to find how many minimum number of registers required to execute it, right? Then you take it, C A plus B, add it. So the result is stored in the R0, but we have to load the C, right? So R, instead of that, you can directly add it. So R0 comma C, you can take it, add. So of that, you can perform the division. So we are doing the division. Then finally, we are storing the result. We are not storing every time. But if you are not storing every time, what will happen? You need to use more number of registers. Earlier, we are not storing. We are storing every time in the main memory. So you no need to worry about whether R0 is changed or not. And the third one, instruction ordering. See, picking up the best order is difficult and that comes under the NP complete. Guys, we cannot say that a particular order will give you the more, right? But we can say that more efficient results. Okay. So the order which is generated by the 3 address code generally will follow it. But changing of the order sometimes will increase the code. For example, you take like this. You're having move R0 comma A. So add 2 comma 3. Assume that, then jump if 0, okay, go to L, assume that, then we are having L, so we are doing it. But how many times we are repeating 100 times? The 100 times addition of 2 plus 3 is 5 only. That is useless. Then you can change this order and you can move it, so automatically in the loop only two statements are going to be executed instead of executing. Of course, just I'm giving you, if something is constant inside the loop, that we can move it so that the number of iterations, sorry, number of statements in the loop may be reduced. So ordering is also important. So in the next video, we'll discuss about the target language and addressing modes. So what we have discussed in this video, just the properties and forms and the issues in target code and what are the major tasks of target.